Hi everyone, welcome to Java Techie. In this tutorial, we'll explore Kubernetes Ingress, what it is, why we need it, and how to use it to expose applications running in a Kubernetes cluster. Okay, alright. So before we dive in, I assume you are familiar with Docker and Kubernetes. If not, I would strongly suggest you to check out my Kubernetes playlist to get up to the speed. Okay, cool. So without any further delay, let's get started. So let's start with a basic overview of Ingress. We'll look at why we need Ingress when we already have options like node port and load balancer to expose the Kubernetes services, or what challenges do node port and load balancer have that led the industry to choose Ingress. So once you understand why Ingress, then you will get a clear picture of what Ingress is. Okay, fine. Let's assume I have two microservices, core service and block service, which is running on a Kubernetes cluster. As you know, Kubernetes offers us couple of methods to expose your application to outside the cluster, like node port, load balancer and cluster IP. However, cluster IP is useful to access the resource within the cluster. So let's stripe it out for now. We'll focus on the node port and load balancer approach. So first, let's discuss the problem using node port service. Assume both my course and block service expose as a node port service, which means a port range between 30,000 to 32767 will assign to each service, right? That's the basic principle of node port service, isn't it? Now, how can I access these two services? It's simple. Since it is a node port service, you can access it by node IP and node port like this. So to access core service, you can define the URL like this. IP and 30001 is nothing the port of your core service and your endpoint. Similar for block service. This looks good, but this approach is something which we can use in our local for testing. In production grade application, user should not type the IP and port to access your services. Rather, you need to provide a host or DNS to access your service. Let's consider I have this DNS with me, that is javatechie.com. So I can map the IP to my DNS so that user can access the service using javatechie.com. Similarly, user can access the block service using javatechie.com, then node port. So by mapping the DNS to the IP, we are not forcing user to pass the IP address manually, rather than he can directly access using the host name. But still the user needs to remember the node port to access your services, which is not recommended in real time. For example, let's say your block service is crashed or it restarted, then once the service will restart, it will assign a new port to it, which you can consider for now 30,018. Okay. Now again, user need to pass the new port, which is 30,018, to access your service, which is challenging, right? But still we have some workaround to avoid giving the port number as a part of the URL. So what we can do, we can set up a proxy server to route all the traffic through port 80. Okay. Now user can directly access it using the DNS name like this. You need to pass to access the core service. You can give the DNS, which is javatechie.com/course, because the node port is mapped to the proxy server with port 80. Okay. Similarly, to access the block service, you can just pass javatechie.com/blocks. That's great. In fact, we are expecting to do the same, but it seems an extra setup or workload for a developer, isn't it? That is why I look into another method, that is load balancer. Now let's see what all challenges we found in load balancer approach. Since here my both the service exposed as a load balancer type service, to access them I need a cloud provider who can provide me a public static IP to access the services like this. I can use the public static IP given by the cloud provider to access the core service and block service. Now since I have the static IP with me, I can map this static IP to DNS, that is javatechie.com. Fine. Next, I can access the service using DNS instead of giving an IP address like this. I can directly give javatechie.com/course to access the core service, same for block service. It looks solve our problem, right? But if you observe, for two service, cloud provider provisioned two static IP, and for that they will charge a huge amount which is too expensive. Now think, what if I have 10 services? Then I need 10 different static IP from cloud provider, which is too costly and it will increase the cost of my project. So again, this approach is not recommended for cost efficiency. So we understand the challenges in node port and load balancer service. Now let's move one step ahead to understand how to resolve it. If we cannot use the node port or load balancer to expose our service to outside the Kubernetes cluster, and these many challenges we can face if we are using these two services, then how we can overcome that? Okay, that is what the solution we are going to discuss now. So let's assume I have 3 microservices and all are running on Kubernetes cluster. Okay, and I don't want user to directly access these services, so I have exposed this service as a cluster IP so that its scope will be within the cluster and it don't have any external access. Now you might have a question, how can user access these services? Wait, so for that what I will do, I will create another pod called Proxy Pod. All the external requests will go through this Proxy Pod, which will then communicate further to your core service, block service and user service. Now this Proxy Pod will act as a entry point to your microservices. So it means you need to expose this Proxy Pod to outside the cluster. So to allow access to this Proxy Pod from outside the Kubernetes cluster, I will expose it as a load balancer service. This way my cloud provider will assign a static IP address to the pod, and then later I can map that to my DNS, that is javatechie.com. Now think practically, when a request comes to my proxy pod, how will it know which service to redirect? Whether I need to delegate that request to the core service or block service or user service, how this proxy pod will identify that? For example, if a request comes with /course, I want the proxy pod to forward it to the core service. Similarly, /blocks should go to the block service, and same for user service. Now, how do we make this happen? That is where you need to define a rules where you can specify the path and corresponding service to redirect. /course should go to the core service, /block should go to the block service, like that, and you need to define a rule. So what happened when you send a request with /course? Now this proxy pod will look into the rules and identify, okay, the mapping URL for /course is the core service. Now my job to redirect that request to the core service. Okay, now based on the incoming path, proxy pod will look into the corresponding service from the rules and redirect the request. Not only path based, you can also set up domain based rule. For example, if request is coming from course.com, then you want to delegate that request to core service. Similarly, if request is coming from blog.com, then you want to forward that request to block service. Like that, you can also define your rules based on your domain. But in this example, we'll focus on the path based routing. Okay, fine. Now, if you observe, the main advantages here is that with a single IP, I can access multiple services and all the requests are routed through the proxy pod. That is nothing your Ingress controller in Kubernetes world, and where you have defined the rules for routing, that is nothing called Ingress resources, which is a native object of Kubernetes. Now the key point to remember, Kubernetes doesn't have any inbuilt support for an Ingress controller, so you can use third-party controller like NGINX, Istio or HA proxy. These are some of the most popular options to use as a Ingress controller. Now I hope you have a clear understanding of what Ingress is and why it's so essential in Kubernetes, and I believe you probably don't even need a formal definition anymore. If we are all on the same page, let's look at the flow we'll use to demonstrate Kubernetes Ingress in practice. Basically what we are going to do, we'll create two simple microservices, course and block, and then we'll run them in a Kubernetes cluster with cluster IP service. So to run application in Kubernetes, we do follow very basic setup, right? We write the Docker file, build the Docker image, then create the Kubernetes deployment and service object, then just apply these to YML file. This is the basic steps we do follow. Again, if you are not aware about it, please check out my Kubernetes playlist. I will also share the link in video description for your reference. Now we will need an Ingress controller, or we will need an Proxy Pod to route incoming request. Since we are using the Minikube, which include the NGINX Ingress controller by default, we will use that for this demo. In the future, we will explore other controller like Istio and HA proxy. Okay, since this is just a demo, we are not going to use the cloud provider to just get a static IP. Instead, we will use the Minikube IP and map it to our DNS. Fine, that is javatechie.com. Next, we will define the path-based rule for our microservice in Ingress resources, so that based on incoming request, Ingress controller will check the service map for that path and forward the request. Okay, this is the basic setup we'll demonstrate. So if you are understand the flow, let's get started with the coding part. So we'll follow this diagram to understand Ingress. First step, we'll create these two services, order service and block service. So to save our time, already I created these two services. This is the core service where I am just exposing one REST endpoint with some hard-coded course object. Similarly, I also created the block service and I have defined a controller who is exposing one endpoint to return couple of block object. Okay, these are the two simple microservices I have created to demonstrate the Ingress path-based routing. Okay, cool. So we are good at the first step. We created these two services. Now the second step, we need to create the Docker image and we want to run it in a Kubernetes cluster as a cluster IP service. So for that, first let's create the Docker image, then build the Docker image and push it to the Docker hub. Then we'll define our Kubernetes deployment and service object to run these two applications in Kubernetes cluster. So just go to the project. I already defined the Docker file for both the application. We are using JDK21. Then I want to generate a jar file of this, and this is the command to execute the jar file. Same I have for core service. This is the simple format of defining the Docker file. Now first let me generate the jar file, then I will build the Docker image and I will push it to the Docker hub. So let me run the mbn install. Let's run it for block service as well. So you can see here build is succeeded, and if you will check in the core service, good, right? Now what I can do, since I have the jar ready with me, I want to build the Docker image. So for that, let me start the Docker desktop. Once it will be up, then we can build the Docker image. So for that, let me go to the course and terminal. Then I will simplify the command docker build -t. I will tag the image name with Java Techie for u, that is what my Docker Hub ID, and I want to give the image name something like course service with the tag 1.0, or I will give 2.0 root. Just execute it. So it created the Docker image. Now let's do the same steps in our blog service. I'll go to the terminal, then I will simply execute docker build -t, then Docker Hub ID, which is Java Techie for you. Then what is the image name you want to keep? I want to keep blog service 2.0 is the tag root. Now if you will validate Docker images, it created both the service course and blog with the tag 2.0 and in a minute ago, right? Now the next step, we want to push this image to Docker Hub. So what you can do, docker push, then what is the image name? Java Techie for you slash blog service 2.0. okay, just enter it. So there is a spelling mistake, just this should be docker, right? Now it will push this particular image to Docker Hub. Meanwhile, let me do the same for core service. Docker push Java Techie for you, that is what the tag name, and what is the image name? Course -service 2.0. Just enter it. So let's check in the Docker Hub now. Just refresh it. We can see these two services, right? Core service and blog service. Now what is our next step? We have the Docker image for this core service and blog service. Now next we want to run it in a Kubernetes. So for that we need to define the service and deployment object. So if you will go to the core service, again these are the basic setup of Kubernetes. If you are not aware, I will share the link in the description, you can check out the playlist. So I have defined the deployment and service object. So deployment is nothing, name of the deployment, what is the number of pods you want to execute, what is the selector name, and what is the container or what is the image you want to run in a pod. So we want to run this same name, okay. Java Techie for you is nothing, the Docker Hub ID, and this is what my image name. So it is already available in our Docker Hub, so Kubernetes can pull it and it will run on port 8080. So this is just deployment object. Now also we have defined the service object of type cluster IP, because I don't want to expose it to outside of the Kubernetes cluster, and I want user to access through the Ingress controller, okay. That is what we understand here. If you remember, we are exposing it as a cluster IP, fine, and 8080 is the port. Similarly, if you will go to the core service, blog service, there also I have defined the service and deployment object. If you see here, this is the deployment object. I need 2 replica, 2 pods, and name of the app, and then this is the container name. This is what the image I want to pull and execute in Kubernetes cluster, fine. Here also I have defined the service of type cluster IP, port is 8080. This is what the simple configuration of deployment and service object of Kubernetes. Now since I want to run these two applications in a Kubernetes cluster, I need to execute this, or I need to apply this Kubernetes manifest file, okay, which is nothing your Kubernetes config.yml. So just go to the terminal, but before that I need to start my Kubernetes. I need to start my Minikube, right? So just open the terminal. Let me zoom this for you. Now here I can simply start the Minikube, start, and I will use the driver hyperkit. I tried with the Docker, but I was unable to ping my Minikube IP. So that is the reason I am using hyperkit. You can also try the VirtualBox or hyperkit, anything is comfort for you, okay. So it will take a couple of seconds, we need to wait. So Minikube is up and running now. To validate that, you can check Minikube status, all are running, right? And if you observe the log, when I start the Minikube, I am seeing something here, Kubernetes Ingress, right? Ingress NGINX. So as I already mentioned, by default Minikube has inbuilt support of this NGINX Ingress Controller. So if you cannot see this in your log while starting the Minikube, you need to manually enable it. So it's just one step. What you can do, you just need to execute this command minikube add-on enable ingress, okay, so that it will be by default enable nginx ingress for you. Just enter it. The ingress add-on is enabled. Fine. Now the next step, let's start executing the Kubernetes manifest file to create the deployment and service object. So let me go to the code service, then go to the terminal, just apply here kubectl apply -f kubernetes config.yml. Now just go to the block service and do the same step here, kubectl apply -f kubernetes config.yml. Now it created the service and deployment object. To validate that things are running smoothly, what you can do, you just go to the terminal and just execute kubectl get all the resources. It's creating the container for block service. Core service is up and running, you can see here. These are the pods we have, because each application we created 2 pod, right? So that is the reason we are seeing 4 pods. Just execute it again, all are running, okay. And these are the service, block service and core service of type cluster IP, okay. And this is what the deployment object, that is what the name we have given, and these are the replica set, okay. All looks good for now. So if you will check the flow, we created these 2 service and we run them in a Kubernetes cluster. Also we enable the Ingress controller. Now the next step is pending for us. Define a Ingress resource where you can define the rules, saying that okay, if URL is coming with /course, redirect that request to core service. If it is coming /blocks, then redirect that to the block service. This Ingress resource we are going to write now. So for that, what you can define, you can create a YML configuration. So better to create it in a separate project, but since this is the demo, I am just adding it in a block service. So just create a file. This is not any complex thing, you just need to define one YML configuration. I'll name it ingress.yaml, okay. Now here you just need to define the rules. So let me add the content of file, then I will explain it. So this is very simple guys, let me explain it. So this is of type object ingress, which is the Kubernetes native object, and the name of my ingress I have defined this. You just ignore this part for now, I will explain in a moment. So I am just defining, okay, this is what the host, and here if you see I have defined the rules, okay. If URL is coming with /course, then delegate that request to the core service which is already up and running in a Kubernetes, okay. If URL is coming as a /blog, then forward that request to the block service which is running in a Kubernetes on port 80. Now why I have defined this? NGINX ingress Kubernetes IO rewrite target $2, and why I have defined this regular expression. So what happened, let me tell you. So let's say I am giving this URL /course, let's say I am giving this URL /course/ what is the endpoint we have in the course? All course, right? Now what happened, when you will define in your ingress file, not here, in your ingress file you have defined $2. It means just stripe out the first URL, then consider the next URL which is your endpoint, API endpoint, okay. So if I will give the URL slash course slash all courses, it will only consider your second path, okay, and it will just simply stripe out your first part. So that is how we are designing, because see, slash course I have not given in my course service, right? It will just accept slash all courses, the URL, okay. So there is nothing complex. We have just defined the rule, hey, if request is coming with slash course, then forward it to course service. If slash blog, forward it to blog service. But the main thing, we have defined the host is javatechie.com, which I don't own. This domain I don't have with me, but I want to use this host for now. Now what I want, now if you want to access the course service, how can you access? You can access it using Minikube IP. So if you see here, if you will open the terminal, Minikube IP, this one, okay. Now after apply the Ingress, if you want to access your course service, you can define HTTP, then your Minikube IP, then slash course and your endpoint. Similarly, Minikube IP, then this slash blog and your endpoint. But that is what I don't want, right? That is what we understand here. I want to, for now, since this is the demo, I want to map my Minikube IP to my domain, correct? I want to do this, I want to map it. How can I do that? Even though this domain is not with me, I didn't own this particular domain. How can I do that? It's very simple step. So open the terminal, you will have a file called etc/host. It doesn't matter which operating system you are using, Mac or Windows, you have this particular file on this particular folder, okay, etc host. Now here what I can do, here I can define, okay, if URL is coming to this particular IP, then forward that request to the domain I am specifying here, or the host I am specifying here. So what you can do, you need to edit this particular file, okay. So run it in a admin access, sudo, I want to edit it, the file name is etc/host, just insert, just scroll down, and here I'll just add what is my Minikube IP. I'll just open another terminal to just get the IP. Minikube, this is what the IP, right? Let me copy this and I will paste it here. If any request coming to this IP, map it to the domain javatechie.com. Fine. So just save it, wq. Okay, now if you will see the file, you can see this, right? Any request coming to this host will be redirected to this particular IP, and this is what your Minikube IP. Before that, you need to validate whether you are able to ping your Minikube IP or not. What is that IP? This one, right? Yes, it's working, right? So when you will try with the Docker, when you will start the Minikube with Docker, you won't able to ping. I mean, I'm not sure whether there is some configuration issue on my machine or what is the issue. So you can give a try with Docker and HyperKit and figure it out, okay. But this is how you can configure the host or DNS. Fine. So if you understand this, we are almost done with all the configuration. Now any request coming to this javatechie.com/course, this javatechie.com we map to this particular IP, and this is what my Minikube IP. Then the request will go to this controller class, NGINX controller. Now this controller will read the rules, which is nothing your Ingress resources, and in rule we have defined /course delegate to the course service. So request will landed here, and this routing the traffic to corresponding microservices is done by this particular person, which is nothing your Ingress controller, okay. Now let's apply the Ingress configuration, then we'll validate it. Just go here, Then we're in block service, open the terminal, apply hyphen kubectl apply hyphen f ingress.yml. You can see here it is configured. So if you want, you can also check the pod service and deployment of your NGINX Ingress. So go to the terminal, just clear everything. I'll just do kubectl get pods of the namespace Ingress NGINX. It's running, right? You can also validate the service and deployment object. Now if we'll check the deployment, it's up and running. If you want, you can also check the log of your pods, Ingress pods. Just copy this, check kubectl logs, and what is the namespace. I'm just executing this to verify that there is no error in my NGINX Ingress controller. So far there is no error and warning. What is this? Okay, these are the old error. Fine, ignore it. Okay, there is no error for now. Now let's try to access our core service and block service. So just go to the browser, then just try accessing your core service and block service. So http then javatechie.com/course, all course is the endpoint. Let me cross validate. Go to the core service. Okay, all course, and what is there in block service? All blocks. Okay, all good. Now just enter this. Can you see the result here? We can able to access our core service with the custom DNS, which is mapped to my Minikube IP, and request is going to Ingress. Ingress is routing the request based on the incoming path /course. So I am getting the response from core service. Now if I'll give /all blocks, this should be blog, right? What is there in Ingress? It is blog only. Just go to the browser, blog, all blogs. I'm getting all the response from blog service. Can you see here? Now I am not manually telling to the Kubernetes, hey, I am sending request to the blog service, I am sending request to the core service. How Kubernetes is identifying which service I want to access based on this particular path, the string which I highlighted. Based on this path, Ingress is taking responsibility to identify the mapped service from the Ingress resources and delegating the traffic to corresponding microservices. Okay, this is what the key role of Ingress in Kubernetes world. So this is all about to know about the Ingress. So in this tutorial we have done the path-based routing. In upcoming class, based on your response, I will plan for domain-based routing as well. Okay, I hope now you understand why this Ingress is essential in Kubernetes architecture. Okay, even in microservice world, what is the key role of this Ingress? So just give a try with the example and do let me know in a comment section if you guys have any doubts. That's all about this particular video, guys. Thanks for watching this video. Meet you soon with a new concept.